Hi, welcome to Systems of Linear Inequalities. So now that you know how to solve a system of linear equations and linear quadratic equations, now you're going to do linear and quadratic inequalities. And you do it the same way that you always would, right? We have to get it into y, slope-intercept form, or y equals, and then we graph like we always do, either in our calculator or on Desmos.com, or if you have Desmos on your phone or your iPad, it has an app to go with it. So let's go over this. Step 1. If necessary, put each inequality in slope-intercept form. Reminder, if you multiply or divide by a negative number, you have to change the sign. This is important. Okay, do not forget that, because many times we do. Then you graph. So remember that if it's or equal to, it's solid, and if it's not or equal to, it's dashed. And then you label your points of intersection if there are any, and then you shade. So we know that the solution of the system is where it's double shaded. And then you check your solution set. So let's try this on just regular linear equations. So if you look at the left side, everything's already solved for. So we can do this. We actually did it the last time, we just didn't make them inequalities. We graphed the first one, right? We've got this one here, and we have their slope is 5 over 2, and our y-intercept is 2. So we start at 2, and then we use the 5 over 2. So remember, I went down 5, left 2, or you can go up 5, right 2. 2, 3, 4, 5, 1, 2. So there's our line, right? And you graph the line based on your points. And there you go. Straight edges are required. In fact, I just used one. It might not look very pretty, but I did just use one. Then, now we have to shade. So this was a solid line because it is or equal to, and then we shade. Remember, if it's pointing left, it's less than. Left, less than. Left, less than. That's never going to change. We always have to remember that. So we're going to shade down. So let's go ahead and shade down. So we're in all of this area, and I'm going to make this a different thing. Not that one. So we're in all of this area. Now remember, this is when you might want to invest in some different colors, alright, so that's clear and easy to see where the overlap is and where it's not. So then we have to shade and draw the second equation. Well, the second equation starts at negative 2, and the slope is up 1 over 2. So up 1 over 2. You grab your straight edge, or your ruler, and you draw a straight line. Sorry, that purple up there is not supposed to be there. Then it is greater than this. So, or equal to. And since it's or equal to, we have a solid line. And then it is greater than, so we're going to shade above. So as you can see, our solution is that double shaded area, which is all of this region. Alright, because that's where we have overlap of purple and blue. So let's do that one more time. Now, I'm doing that one more time because this equation you actually have to solve for y for. And it's not as simple as just using the slope-intercept and going from there. We have to put it into slope-intercept form, but that's okay because we will be experts at this, right? So we have this equation, the x plus y is less than negative 3. So we need to get y by itself, so we need to get rid of that x. And to put it in slope-intercept form, the x has to go first. So we have negative x minus 3. So let's go ahead and graph that. We have a negative 3. We start at negative 3. And remember, your slope is always the number in front of x. And that imaginary 1 is in front of x, a negative 1. And you can always put a 1 under it. So we are left 1, up 1. Or down 1, right 1. So if we go down 1, right 1, left 1, up 1. That's what we have. All right, that's our line. So you grab a straight edge, but before you draw it, which I didn't do on the others, you have to think, is this going to be solid or dashed? Well, this one is going to be dashed because it is not or equal to. It does not have a line under it. So we need to draw dashed lines. Then, is it greater than or less than? Well, this one is less than, so we are shading down. Now we do the other one. So we have 5x minus y is less than or equal to negative 3. Well, again, we need to get the y by itself, so we need to move the 5x over. We get negative y is less than or equal to negative 5x minus 3. Now you have to remember, we don't want to know what negative y is, we need to know what positive y is. So you make this a positive by dividing everything by a negative 1. But, if you remember that first page of this section, if you divide by a negative 1, you have to change the sign. You have to change the sign. So now, we have greater than or equal to positive 5x plus 3. And now we can graph it. So we have a 3, and our slope is 5 over 1, because remember, you can always put a 1 over it. So we're either going to go up 5, right 1, or down 5, left 1. One of the two. And because of my picture restraints, I'm going to go down 5, left 1. Oh, hey, look, that's where they cross. So that's our line. Is it solid or dashed? Solid, because it is or equal to. And then which way are we shading? Well, it's greater than, so we're shading up. And then this area right here, all of this, the red emphasis, is our solution, because that's where it's crossing twice. So, now that you've done that, we're going to do the same thing, but we're going to do them with systems of linear quadratic inequalities. And as long as you already have it in y equals, it's very, very easy to do. Now remember, you can always go to Desmos.com to help you with graphing, because graphing quadratics are not very easy, or they're not very straightforward. You can't just graph the y-intercept and go from there. You have to look at a picture and plot points. So what I've done is gone to Desmos.com and graphed it. Now, the first one, the 2x plus y is greater than 10, that is just a straight line. And we need to solve that for y. So let's do that. You subtract 2x, and you get y is greater than negative 2x plus 10. So we can start at 10 and go from there. The slope is negative 2 over 1, so we go down 2, right 1. Down 2, right 1. And before we draw our line, we have to ask ourselves, is this solid or dashed? Well, this one is dashed, because it is not or equal to. So we have this dashed line going through. And then the shading just like before. Well, it's greater than. So we are shading above this line. So all of this area. Now, I put y equals 9 minus x squared into Desmos.com or into my calculator, and I got points from that. Remember, you can hit Control-T in your calculator if you have an Inspire, and it'll give you a bunch of points. So, one of the points that I found on this graph is 0, 9. So I'm going to plot that point. Then, and it's already in y equals, so we're good. Then I have these points. And I know that my x-intercepts are negative 3 and positive 3 by looking at my points. So I'm going to sketch what this looks like as a parabola. It's not going to be perfect because it's not actually a straight line, it's a curve. And I'm not perfect at drawing curves, but you're going to get the gist of the idea. The point is that you have good points. And this is dashed because it is not or equal to. So you can have a dashed parabola. like I said, not perfect. And then the other side. Then we have to ask ourselves, is this less than or greater than? If it's greater than, it's going to be on the outside of our parabola. If it's less than, it's going to be on the inside of our parabola. This is less than, so we are shading just what's inside the parabola. So if you notice, these shaded areas never cross, which means that we don't have any solutions at all. And we definitely don't have any solutions because even though it crosses at one point, those points do not exist on the actual line because we're not including the line. So this has no solution. Let's do this again. 2 more times. You'll be okay. So again, we need to have x plus y less than -3, and I'm sorry, I'm looking at the wrong page. Less than -6, less than or equal to -6. And we need to solve for y. So we have x plus y is equal to -6. We subtract x from both sides, and we get that y is less than or equal to -x minus 6. Then we go over here, we plot the 6, that -6. We use our slope, which is -1 over 1, so we are going left 1, up 1, or right 1, down 1, and we're drawing a line. Now this is or equal to, so it's solid. So you have a solid line right there. Then we have to shade. Well, it's less than, so we're shading below. So we are down here. The second equation, y is less than x squared plus 6x. Again, you put that in your calculator and you find good points. Some good points in this graph are our x-intercepts, which is -6 and 0, and our vertex, which is -3, -9. So -3, -9. Now, this is less than, not less than or equal to, so we're going to have a dashed line. So we have a dashed curve going up, and one on the other side going up. And this is less than, so we are shading on the outside because it is facing upward. Okay, so this is not inside, this is outside. So now we have a different type of double shaded area, but it's still the double shaded area. It's the part that goes through here and then goes around the parabola and then goes through there. So it's all of that area right there. All right, let's do this one more time. Last one, number 6. These are both already solved for, so that's nice. So we can just graph. And I'm going to graph the first one in blue. So we have the y-intercept is 3. We go up to 3. Slope is 1 over 1, so up 1 over 1. It is solid because it is or equal to, so we are drawing straight line, solid, using a straight edge. And it is greater than, so we are going to shade up. So we're all up there. Then, for the other one, we're going to use purple. And this, again, you put in your calculator, you put into Desmos.com, you do something to find good points. One good point is a vertex. So our vertex here is 2, 4. Then your x-intercepts. Here, there's 0 and 4. Now this parabola is going to be dotted because it is not or equal to, again. So we have this, and we have this, and it is greater than, so we're going to shade above the parabola, which is outside in this case. And then the solution happens to be y is greater than or equal to x plus 3 because everything above that line is double shaded. So there you go. There are your notes. It wasn't that bad. Be ready to do this in class. Have a good day.